Okay, second definition of mole. It starts with a C. If you're from my class, what does mole also mean? Co-something. Coefficient. And that means the number, is it the number in front or the number behind? It means the number in front. And we're going to use that today. A third definition is grams. And we're going to use that for molar mass. A fourth definition is a mole to mole ratio. A mole to mole ratio. And that's the hardest part of chemistry, is using the mole to mole ratio to find out how many grams of something you need. Last but not least is the conversion factor. And it's kind of like a wild card in Uno, where you get to choose your own color: red, yellow, blue, green. And in chemistry, you can choose grams, coefficients, Avogadro's number, this huge number, or you can just use mole. Okay, so there's 4 uses for that conversion factor. Today we're going to use mole to mole ratio, we're going to use grams, we're going to use coefficient, those 3. You'll each need a periodic table, so go ahead and give these back once you're done. Pass those back, please. Pedro, go ahead and take that. And I want you to find these elements, and we're going to add them together. So write down those 4 substances. And how much does K weigh on your periodic table? You can use atomic mass. You should each have a calculator. If you don't, you can come get one. How much does K weigh? Find K. 39.10. So put that in your calculator. And then add that to Br. How much does Br weigh? How much is Br?
79.
79.9. What does that equal? You guys doing this in your calculator? What is those 2 added together? 119. Good. Find Li, and that's what molar mass is. Find Li. How much is it? 6.94. Add it to oxygen. How much does oxygen weigh? 16. And then add that to H. How much does H weigh? 1.01, which makes what? 23.95 grams per mole. And that's the molar mass. So we've been using decimals this whole time. Now that we're going to use more than 1 atom at a time, let's take the decimals off just to make life easier. Find Na. How much does Na weigh? 22.99, which is pretty much what number? 23, but there's 2 of them. So what's 23 times 2? 46. So let's write it on the side here. And carbon weighs how much? 12. And you're going to add it to 3 oxygens. How much does oxygen weigh? 16. But how many oxygens are there? There's 3. So 16 times 3 equals how much? 48. Add these three together, and what do you get?
Six.
106. Good. Grams per mole. That's molar mass. And this one's even more advanced because you're going to multiply the 2 times the 3 and the 2 times the 1. Let's start with the BA. How many BAs are there? There's 1, and how much does it weigh? 37. Nitrogens, how many nitrogens are there? There's 2. And how much does 1 nitrogen weigh? 14, but there's 2 of them, so that makes 28. And then oxygen, there's how many?
60.
There's 6. And how much does 1 oxygen weigh?
16.
16. What's 16 times 6? 96. Add those 3 together, what do you get? 261 grams per mole, which is the molar mass. All right, so that's the first step of today. You can draw a line, and you'll find molar masses of 7 different equations in your assignment. Now the second part is mole-to-mole ratios, which is the hardest for most high school students. We'll do our best today and learn as much as we can. We're going to use mole-to-mole ratios to find amounts desired. In chemistry, we always want to find how much stuff we have, and this is an equation where we're going to find how much stuff we have. The problem today is 4 grams of C3H8 are provided. Find grams of CO2 desired. So the first step is to write a beginning and end to your problems. The beginning of the problem, is it 4 grams or is it unknown grams of CO2? What's the beginning of your problem? Is it 4 or unknown? Like if someone says 4 grams are provided, but we want to find CO2, what number do you start with? What's the only number they give you? 4. So write down 4 grams, and then of what kind? C3H8. And what are we looking for? What's desired? What's it say? Grams of CO2. So draw a question mark, grams CO2. Now you're going to write 3 separate steps to use your mole-to-mole ratio. Always use 1 mole in the beginning and 1 mole at the end. You're going to find the molar mass of your beginning. And then you're going to find the molar mass of your end. And then we'll do the third step together. So what is the molar mass of C3H8? How many C's are there? 3. So multiply 3 times however much it weighs on your periodic table. Go ahead and shout out an answer once you find it. 36, and then you're going to add that to 8 hydrogens, so 36 plus 8 hydrogens. How much does hydrogen weigh? 1. So 8 times 1 is 8, which equals what? 44. Good. Let's do the last molar mass. How much does CO2 weigh? Find C, find 2 O's. Anyone find it? Carbon plus oxygen plus oxygen. 44. Good. So molar mass, molar mass. The middle is going to be coefficients. The middle are coefficients. What's the coefficient of your beginning, the C3H8? Well, what's in our equation here? Remember, coefficients are the numbers in front. What number is here but invisible? A 1. There's an invisible 1 here. So the coefficient of C3H8 goes at the bottom. And what's the coefficient of your end, CO2? Did we balance this equation? We have not. In order for anything to happen, you have to balance the equation. So let's do that step really quick. Balancing is counting. So how many C's are on the left? 3. How many are on the right?
2.
There's only 1 C, right? That 2 belongs to the O. So what coefficient should I put here to make 3 C's?
2.
2 would make it a 2. I need 3 because I started with 3. When you balance equations, remember the law of conservation of mass. What you start with is what you end with. So if I start with 3 C's, I must end with how many C's? 3. So what number goes in front?
3.
A 3. How many H's do I start with? 8. So I must end with how many H's? 8. What coefficient should I put here? If I put 6, it's 6 times 2 making 12. That's not 8. 4. 4 times 2 is 8. Now let's count our oxygens. Hopefully we're balanced. How many oxygens are here at the end? 4 times 1 is 4. So 4 oxygens. And how many oxygens are here? 3 times 2 is 6. 6 plus 4 is 10. So if you end with 10 oxygens, you must start with 10 oxygens. So what coefficient goes here?
5.
5. Now let's go back to our mole-to-mole ratio. What coefficient is in front of CO2? That's 3. Good. And that's all we're going to do today. We're not going to find the final answer. There's no time. But we are going to set up our mole-to-mole ratio, find molar mass, and then put in the coefficient. Okay? So there is 9 of us. Let's give you 4 here. And you can pass that back. Pass that back.